Okay, we're live and we are recording. So hopefully this will work out. Again, I remind you to please keep those side conversations down to nothing for me, please. All right, so here is today's notes. We're going to be looking at measuring segments and measuring angles. So if you haven't done it yet, please set up your notes in this fashion. On the left-hand margin, if you would, please make sure you write the word segments, because this portion is going to be talking all about the segments. Things you're going to need today: you will want a pencil. You might want a pen, and I'm going to recommend a couple different colors of pens, especially if you're like me. I like these standard 4. Okay. These are my 4 favorite color of pens. And I gave each and every one of you a protractor. So you will need a protractor. All right, here we go. So a few days ago, kind of toward the beginning of the year, we talked about the ruler postulate. And it went pretty quickly. We talked about it, and then we didn't really touch it again. So I want to ask you guys, what do you remember about the ruler postulate? And if you don't remember anything, go to your notes, flip back a couple days, and find what the ruler postulate says. And let me know what you think. What is the ruler postulate? Love the sound of papers flipping. Means you're looking through your notes. Thank you. Points on a line can be paired with real numbers so that the distances between them can be measured. I'm not going to write the whole thing. We'll write just a part of it as a reminder. So points on a line can be paired. Try to do my best projector handwriting. Paired with real numbers. All right, there it is. And I'd like for you to grab your protractor, doesn't matter which kind you have, and I'd like you to draw a line as long as your protractor is, kind of this big edge here, okay? Now it can be super straight and even like this. You can make it kind of slanted at the side to an angle. You can make it straight up and down. I really don't care where you put this line. Just please draw a line. Use your protractor. Your protractor to make it really straight. And since this is a line, make sure that you please have some arrows. I'm going to zoom in here on this. Whoops, too far. There we go. As long as the edge of your protractor. So you have a nice long line sitting there. All right, and this says that points on the line can be paired with real numbers. So I'm going to start pairing some real numbers to points. Remember, this line has an infinite number of points. There's too many of them for me to count. I'm going to pick one of those points, maybe somewhere here in the middle, and I'm going to pair it with the number 0, because 0 is totally a real number. And I'm going to start over here on the right, and I'm going to start going with positive numbers because I'm in a happy mood. And positives are never sad. No one laughed at that joke. It's okay, it's not that funny. And now I'm going to go to the left of the 0, and I'm going to do some negative numbers. Please don't commit suicide, negative numbers. It's okay. We still like you, despite your negativity. Okay, so we've got some negative numbers, and we have some positive numbers. Those are all real numbers. Going to show you some other real numbers. Somewhere in here between 3 and 4, we have the real number pi. Pi is totally a real number. And fractions are real numbers too. So those are also real numbers. So those decimals that don't make any sense and go on for forever, and then any kind of fraction or decimal, those are also real numbers. All right, so we're not going to use those decimals right now, but I just wanted to show them that they're there. And I need some points on my line because this was all about finding the distance between some. So I'm going to put a point here, and I guess I'm going to put a point here, and now I need some names. Help me out, shout out some names for these points. K and A. K-A. All right, we've got some names for points. There we are, and now we are concerning ourselves with the distance between K and A. So we're worried about the distance between K and A. Between his two E's together, I always forget an E. Very sorry about that. Between K and A. And the symbol to say that's going to look like this right here. It's the symbol for the line, right? But we don't have any symbol on top of it, right? So some of you got some worksheets back and you were naming lines and I marked them wrong even though you had all the right letters, and it was because there was no symbol on top of the letters. It's because if you don't put the symbol on top of the letters, you're not talking about the line, you're talking about the distance between the points. Okay? So here we are, the distance between the points, and I'm going to give you a formula. Here it is. There's our formula. And we're going to talk about the parts of this formula. This part right here, these two little bars here, and I've got an arrow pointing to one and a kind of a star pointing to the other so that you know that they're together. That's the absolute value sign. We'll talk a little bit more about what the absolute value sign is and what it does in a few moments. And then we have the point names. In this little formula, these point names are actually talking about the coordinates, the numbers of the points K and A. I was about to write paints. The points K and A. Okay. So there's two ways to go about finding distance. There's the way I'm about to show you right now, which is the long justification way. It tells you all the reasons why this is the distance, and no one can argue with you when you're done writing it this way. And then there's the super fast, short, and easy way. I'm going to show them both to you. All right, so because this is an argument and I'm making a justification, I'm going to put my justification bar there. And the ruler postulate is what allowed me to use this distance formula. Now, if you took Algebra 1, you were given this weird distance formula, and they told you this is the distance formula. And it had a square root, and it was really long, right? And they made it seem like that was the only distance formula ever. And they're right, but only when you're working with that XY graph paper plane. Okay? If you're not on that XY graph paper plane, that distance formula doesn't work. This is the distance formula for a line. So whenever you're on a line and you're trying to find the distance between 2 points, this is the formula to use, not that other one with all the weird square root stuff to it. Okay? Holy cow, thank you, phone. All right, so this is the distance formula of the line. That's what we're going to use. I'm going to scoot my work up here just a little bit. There we go. And now I'm going to start substituting in for things that I know. What is the coordinate, the number of K? -6? 5? My bad handwriting again? 5. Yeah, but it's my bad handwriting.
No, it's actually different.
Ah, okay. So on his it's -6. On mine it's -5. Okay, no problem. You run it with your 6, okay? Don't change it on my account. Okay, so I'm going to write up here -5, but you're putting -6. Okay. Minus, and now what's the coordinate of A? 6. Lovely, thank you very much. And substitution allowed this to happen. So we're going to put in here substitution. And then I'm going to put my little break bar that says I'm done with that particular part of my argument. And next up, I'm going to do some straight up subtraction. All right, what is negative 5 minus 6? 1? It's a negative number?
0.
0. Regular one because the 5 is negative. Okay, let's go to our calculator and check. And then I can sit with you guys in, or maybe do, because today's Movie Monday, right after school. So today I can do a small, if this technology is working, I can do another small video presentation for you guys explaining why your calculator will give you the answer it's going to give you. What I'd like you to do is turn on your calculators and find the little button underneath the escape key. Underneath the escape key. It looks like a calculator that's going really fast. Okay, that's the scratch pad button. I want you to push the scratch pad, and in the calculator scratch pad, I want you to type in negative 5 minus 6 and shout out for me the number the calculator gave you.
Negative 11.
Negative 11. All right. Now, if you're confused as to why it's a negative 11 instead of a 1 or negative 1, I will do another video another time to explain that for you, okay? So that you can watch it. But for right now, we'll go with what the calculator says, and we'll put negative 11. All right. And the very last thing for us to do is to take care of this absolute value thing. Can y'all tell me what you remember of absolute value? Even if you think it's absolutely nothing. Awesome. Even if you think it's wrong. Like, just go out there. Take a risk for me. Absolute value.
The exact value.
The exact value, yeah, because that word absolute. But it's an exact value from a specific number. What number do you think that is? 1? 0. It is 0. It's the exact value. We're gonna clarify, instead of value, we're gonna use the word distance. The exact distance a number is from 0. Beautiful. So negative 11 is how far away from 0?
What?
Negative 11. How far away is it from 0?
11.
It's 11. So there's the absolute value of negative 11. It's basically the number without the negativity. Okay? If it was a negative number, they gave it Prozac. And now it's positive. No, nothing. I feel okay making that joke because my sister had to take some. She was a very sad person. No? No, okay. It's a lame joke. Y'all can laugh at my lameness. That's okay. Ha ha ha. All right, so there it is. There's the distance from points K to A. It's a really horrible joke. I have to cut that out of the, when I go to edit, just cut that part out. All right. If you were asked to do an open response skill check, okay? So on the skill checks I give you, the question was, what's the distance between K and A? And I said, write your answers on your own sheet of paper. And that was all I did. I would want you to show me all of this. If you just gave me the answer and you were wrong by even one number, I couldn't give you any credit whatsoever. I'd have to count the whole thing wrong. But if you gave me all of this and it was just this number down here that was a little wrong, I could give you credit for all the other 3 steps because your thinking was in the right spot. You just wrote the wrong number down. All right? So if you show me all of your thinking, I can give you, at the very least, some part of the credit for the question. Now, if you're facing a multiple choice test, at that point, I don't care your thinking. I don't care how you get to the right answer.
How come it's positive?
Right here?
No.
This one. Okay. So let me back up just a second. Absolute values is the distance the number is from 0. How far away is this number from 0? It's 11 units. That's why.
So it's always going to be positive.
Always going to be positive. Always. Okay, thank you. All right, so this was the open skill check. Trying to get back to where I was. Thank you. In a multiple choice question, I don't care how you get to the right answer, I just want you to get there. And bubble it in. And make it all neat and pretty and dark and all that stuff that you have to do on those bubble tests, right? So you can start at any point you want. I'm going to start at K, and now you just count until you hit A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Notice how I skipped all those partial numbers in between, those fractions and those decimals? I went to just the whole numbers because I'm counting by whole numbers. I'm not counting by fractions. Okay? So there's 11. And it didn't matter which order you did it in. If I started at A, I'd count to K. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's still 11, regardless of which direction I moved. Okay? So open response skill check, I need to see all your thinking. Multiple choice test, you can just count the things and put the number as the answer. Whatever's fastest for you. Cool? All right. I'm going to zoom this out a little bit. I'd like you to please take your pen or a highlighter or a marker or whatever big writing tool that you are using, and please draw a giant line the whole way across your paper. Mine is totally not straight. From one edge of the paper clear across to the other. Do that for me right now. Here, I'm going to make it a little better. Sort of. There we go. Big line across the whole paper. And then you're going to label this section in the left-hand margin as angles. So we're still talking about measuring stuff, but where the first part of the paper was talking about measuring segments, now this part of the paper is talking about measuring angles. And before we can measure angles, I'm going to zoom in here real tight on the margin. I need to define for you what an angle is, and here's that definition. Angles are formed by two rays that share an endpoint. Remember that a ray is a part of a line. It has one endpoint and then goes forever in one direction. It's like just half a line. So now an angle is two of those rays, but they have the same endpoint. And those pieces of the line shoot off in different directions. So write this definition down for me. Angles. And notice the red star. This is important. Oh, that was my finger. All right, going to zoom it out just a little bit. Let's draw some angles. A lot of you did the angle assignment for me where you took your straight edge and you drew for me 6 angles using your straight edge. We're going to use the same process. In case you haven't done that assignment, I urge you please to grab some paper and do it today, because other students will need your work to complete the next part of this activity today. So take your protractor, we're going to use our straight edge, and we're going to draw an angle. Doesn't matter where you put this line. I'm going to put it over here, I guess. I'm going to make it kind of big. There it is. But remember, this is a ray, so it has an endpoint, and it goes off forever in another direction. And then because this is an angle, I need 2 rays. I'm going to line up my protractor straight edge so that it's on that vertex, on that endpoint. And I'm going to draw another ray going off in some other direction. And you can make this, again, as skinny or as wide as you want. I made mine kind of wide today. Don't forget that arrow. There we go. Let's skip over and pretend to be in biology. We're going to do some anatomy really quick. These rays right here, we're going to call them legs. I got legs. And I know how to use them. I gotta find that song. Add it to the.
Well, that was a joke.
It totally was. The joke in the form of a song. This angle's got legs and it knows how to use them. This right here, the shared endpoint is called the vertex. So the vertex is the shared endpoint. There it is. Now we are going to measure this angle that we have drawn, and I've got a number of different protractors that I'd like to show you. Because I don't know which kind you guys have. I just handed them out randomly. Alright, so in all cases, your protractor has the straight part and it has the curvy part. And they all have a vertex finder. In this little one, it's a little hole. I have a big one that a lot of you have that also has a hole. That's the vertex finder. Some of you don't have a hole, you just have this line here that goes to the edge. Where this line and this edge meet, that point is the vertex finder. Some of you have one that looks like this line and this line, where they meet that point is the vertex finder. So regardless of what kind of protractor you're using, you need to take your vertex finder and set it over the vertex. And then you see this leg here, and then this baseline, this guideline right here that goes to the 0 and the 180. Turn your protractor so that way that leg and that guideline match up, and make sure your vertex is still on the vertex finder. Okay? So you're matching up the leg and the baseline, and you're making sure the vertex is in or on the vertex finder, depending on what kind of vertex finder you have. And then you're going to read from this leg to the other leg. The question I get is, which set of numbers do I read from? Well, when you start counting at 0. I don't have anything, and then you go up from there. 0, 1, 2, 3, 4. So same rule applies. Start at the 0. So in this case, I'm not going to start here at the 180 and go to the 70. I'm going to start with the 0, the inside numbers, and go up. 10, 40, 60, 90, 100, 110, it looks like. My angle ended up being 110 degrees. Okay? That's how you use this protractor. What I'd like you to do at this time is I'd like you to write over here in whatever blank space you happen to have. I have a lot of space here on the right-hand side. You do it wherever. My steps to measuring angles with a protractor. And I would like you to write whatever steps you need, however it makes best sense to you, to remind yourself of how to use the protractor properly to measure this angle. Or to measure any angle, rather.